Hi, Ryan Paracha here with Oakmane Media, here with a tutorial in After Effects on how to use expressions to create tangential motion. So if we take a moment to look at this comp here, you can see what I mean. These arrows here are animated in an arc, but what is spectacular, or rather stands out about them, is that they rotate to follow the direction of movement. Now this might not seem like a very big thing, but actually After Effects will not automatically do this for you. So in order to animate their rotation manually to follow the direction of movement, it would be pretty painstaking. So if you look here, I have this this expression set up here, which we're going to go ahead and rewrite so that you can see how it works. So I'm going to go ahead into this composition over here. And if we have these crudely drawn planets here, and if we wanted to get this rocket from this crudely drawn Earth to this crudely drawn Mars, we could go ahead and open the position property, add a keyframe, scrub forward a little bit, and drag it to the end. And then we have some nice movement. But this is pretty boring. So if we wanted to add in a little bit more, and we click and drag it like this to make it a little bit more exciting, we could do that. But now the rocket always faces forward, and it doesn't look quite as realistic as if it were facing the way it were moving, which is, I've been calling it tangential movement because it's facing on the tangent line. So if we go over to the rotation property by pressing R, I'm actually going to press Shift R to bring it up here. First thing you actually want to do is grab an angle control. You can just type angle in over here. You'll see I've already done this. Type angle control and just grab it onto the layer. I will talk about this a little bit later, but it's good to do now so you don't have to break your workflow later. Anyway, let's get into this expression here. If you press Alt and click on the stopwatch, it'll let you type in an expression. So we're going to start by making a couple variables for ourselves. Keep in mind, a lot of this could be done on less lines by combining steps, but to keep it simple, I'm going to be breaking it up a little bit more. So the first variable that we'll need is the time that we are currently at. So current time is what I'm going to call this variable. Set that equal to, now there's a variable in After Effects called time that you can type in, and that'll get the time of the current time of wherever the playhead is. But the problem is this unit is seconds, and we need frames to be as accurate as possible. So we're actually going to use a function called time to frames, and then open parenthesis, and this is where we're going to put time. Close the parenthesis and end that line with a semicolon. On the next line, we're going to get the time of the previous frame. So to do that, it's very similar. Past time, again, you can name this variable whatever you want. Set that equal to time to frames. Now open the parenthesis and type time again, just like before. But now we're going to subtract 1. Whoops, only 1. And this is going to get the previous frame. Also, it's important to note that I'm subtracting 1 outside of the parenthesis. Otherwise, we would be an entire second behind, and we only want to be 1 frame behind. Now I'm going to end that parenthesis and hit enter again. Now to get the current position. Set that equal to, and grab the pick whip here, and select the position property. That'll just automatically type in this expression for us. And if you don't have the position already up, just press Shift P. Make sure to click out of the expression first, though, and that'll bring the position property up. Okay, and now we can just end that line. And now we need the past position. And we're going to make use of a pretty cool function that I found. So we're going to do this again, where we get the position. But now you're going to type dot value at time. And this does exactly what it sounds like. It will get you the value of a property, but not at the current time, but at a specified time. And we need to open up the parenthesis to tell it what time we want. Now, we have this past time here, but this unit is in frames right now, and we want to give value at time the value of seconds. So what we're going to do is do the reverse of what we did up there and type frames to time. Open parenthesis and type past time. And close that one, and you need to add another closed parenthesis. And now hit semicolon. Alright, now that we have these variables that we need for now, it's time to start our condition. And it's important to make a condition because if you have not picked up on this yet, basically what we're doing here is finding the instantaneous slope at every point. And the problem with that is that if it doesn't move or doesn't move on the x, we're going to be dividing by 0, which we can't do. So to fix that problem, we're going to make a condition, which is if, open parenthesis, and our condition is that the current position, and we need to specify the x value of that, so do that by typing open bracket 0 close bracket, because the 0th element is x. And if this is confusing to you, just note that most programming languages, including this one, will start counting at 0 rather than 1. Subtract past position. Again, we want the 0th element, or the x value of that. And we want to make sure that this is not equal to 0, which is done by typing exclamation point equals sign and then 0. Close parenthesis. Now open a curly bracket and go down a few lines and close curly bracket. We're going to fill that in a moment, but right here what we're going to do is do the else statement so that we can just kind of fix this problem if it would otherwise be dividing by 0. So inside this else, what I'm going to do is I'm going to pick whip. I'm going to grab the pick whip here and drag that up to this angle control. Basically what that will allow us to do is in the case where we would be dividing by 0, which would be, like I said before, either the rocket isn't moving at all or it's only moving up and down, this is going to let us manually control the angle. So now type a ending a semicolon there. Alright, let's come back up inside here to do the main part of the code. As I've already said, we want to find the slope. So to do that, we're going to go ahead and type in slope, make a new variable, equals, now we're going to get the difference in the y values, which is the current position, and we want the first element, which is the y value, subtract the past position, and we want the first element. Now, we actually want to go ahead and throw this calculation right here into parentheses because we also have to divide that by the same thing but with the x values. So you can actually just copy that, copy that and paste it again over here and just change these ones to zeros so that we're getting the x values. And this right here is where we would have a problem if we had to divide by 0. Anyway, now that we have the slope, this is the slope at each point, or the slope of each tangent line. And like I just said, that's the tangent. So if you know anything about trigonometry, you can get the angle, or the theta, by doing what's called the inverse tangent. So we have the tangent, we need to get the angle from it. So to do that, we're going to type angle to make a new variable, equals, and we want math dot a tan. That's going to give us the arctangent or give us back that angle. But we need to tell it what we're getting. So we're getting the arctangent of the slope. And now end that right there with a semicolon. The problem is, though, this is giving us radians. Arctangent gives us radians. We want degrees. So we type in radians to degrees, and then open parenthesis and type in angle to get that angle in degrees. And now if we click out of here, you'll notice that the rocket will now follow the path. And you notice it rotates back straight here. If you don't like that, what you can do is look at what this rotation is here, which is negative 8.5 at this last keyframe here. And if you come up to this angle control, you can type in negative 8.5 and click out, and now you'll see that it just sticks right there instead of rotating back to be forward. Now, one other thing I want to show you really quickly is you can speed up your animation process even more quickly if I go ahead and turn off the position keyframe here. And I'm just going to turn this back to 0. So now we have no more animation. And what we can do is, let's say we know how we want this rocket to move. We know the path we want it to follow, but it might be difficult to do that with the position keyframes and stuff. So you make a new solid. I'm going to delete this real fast. Make a new solid. Doesn't matter what it's called, doesn't matter what color it is, but grab the pen tool. I'm going to turn off the eye so you can see what you're doing. And go ahead and let's say we want it to come this way. We want it to come this way. And then this way, and then back up, and then into Mars, right there. Now we have this path, and actually I can see a problem here, is that this is going straight up, which is going to give us a little bit of a problem because we are doing the, looking at, slopes and tangents and stuff. So I'm going to try to finesse this a little bit to make it less steep so that we're not going to have as much of an issue. And now that we have this path drawn, we want the rocket to follow that path. And this is something I just recently figured out, actually. If you press M on this layer to get the mask path, click that and press Control-C to copy the path, you can actually come to the rocket layer, press P to get the position, and if you click it and paste into the position, it will actually paste that motion path in here for you. And look at that. The rocket will automatically follow that path, and because it's running this, if I press Shift R to bring up rotation, because it's running this expression here, it will actually point in that direction that it's moving. So if I turn that off real fast, you'll see now it's not doing that, and that looks really silly. If I turn it back on, it looks just fine. And one last thing is we go to the end, like I did before, that's 64.3, so if we set this up here, 64.3, and now set a keyframe, go back one frame and set it to 0, so that at the beginning it will start off on 0. Now we have this pretty cool animation here that didn't require too much work other than just typing in a little bit of code. So I hope that this was a very interesting tutorial, gave you a little bit of an idea of how you can use some math and some programming inside of After Effects to speed up your animation process. Again, my name is Ryan Paracha, and this is with Oakmane Media.